Good afternoon, everyone, and welcome back to this lovely web project from the Italian chapter of the Marie Curie Alumni Association, Voices of Interest, where we chat a little bit about the exciting and important discoveries that the members of our community are working on. If you missed the first three episodes, you can find them on the Marie Curie Alumni Association Italy chapter profiles, either on YouTube or LinkedIn. And so now we are pleased to have as our fourth guest Dr. Valerio Francesco Anese. So I will give you guys a wee introduction. Valerio studied his undergrad and master's in electronics engineering at the Politecnico di Bari here in Italy. He then worked on cyber physical systems as a research assistant for 2 years, always there in Bari at the Politecnico before moving to, and now I will be a bit biased, probably one of the best cities in the world, Glasgow, to study his PhD in electronic engineering. Once he finished his PhD, he worked as a postdoctoral researcher associate, always there in Glasgow Uni for a couple of years. And then in 2022, Valerio joined the Center for Nanoscience and Technology at the Istituto Italiano di Tecnologia in Milano, where he continues to develop his research on edible sensors. So, welcome, Valerio. How are you?
Hello. I'm good. What about you?
I'm good, thank you. Today has been a cloudy and windy day, so in case my hair has blew over, it was hard to come here. Well, let's go into it. So basically, I would like to start asking you if you can tell us something about yourself, either if it's your research or your interest outside your work, just because also, as I said in previous episodes, what we want to do is also to show how, like, we are normal people, we are researchers, but we are like everyone else. We chose this beautiful work of doing research, but at the end of the day, it's just another job, no? So what can you tell us about yourself?
Yeah, so welcome everyone. And as you mentioned, I am an electronic engineer. I come from the south of Italy, but yeah, soon I decided to pursue a PhD, and I moved to Glasgow. I accepted an offer for a PhD in Glasgow in engineering. And I had already been in Glasgow for my Erasmus during my bachelor's degree. So for me, it was already, I was very happy to move to Scotland. So during my bachelor and master in the south of Italy, I did this student exchange. And I think this introduced me very quickly to the world of science, the world of research, and I immediately loved it. I spent more than 5 years in Scotland, and of course, it's very interesting to see that other people that graduated from Scotland, Glasgow, are doing great, just like you, just like you, Mauricio. And it was great. I spent more than 5 years. I did my PhD and a first postdoc. And my PhD and postdocs, they were oriented towards point of care and ingestible electronics. However, during my time in Scotland, I really enjoyed the Scottish landscape. I immediately fell in love with the sceneries, which are, I mean, it looks like you're in a movie. It's really magical. It's great. And I also in Scotland experienced major political and historical events like Brexit and COVID. And soon, soon Scotland became like a second home. So I'm looking forward to go back in a few months on holiday to meet some friends and to see what's changed. At some point in my career, I decided I wanted to take over a new challenge. And in 2022, I saw this job post for a postdoc in Milan. And the project was called RoboFood. And to me, the name already was, okay, wow. We are talking about doing robot with food materials. That's, very interesting. And of course, as I mentioned, I was already working on ingestible. So for me, it was a very nice job application. So I decided to apply. And I was contacted very quickly, and I got the job in just a few days. So just in a very short time, I decided to move to Milan, and I am in Milan since 2022. And as soon as I arrived, I was exposed to this new world of using food material, which are safe, which are degradable, but also that have electronic properties to be used in miniaturized robots. And from there, my mind triggered, and I proposed a Marie Curie fellowship, trying to merge my PhD and my new postdoc in Milan. And so I applied for my Marie Curie. To be fair with you, when I mean, I knew about the Marie Curie program by chance, just talking to people, talking to colleagues. And but I knew it was very competitive. But I still applied and I spent a lot of efforts, and it was, I mean, I got a very nice score. And so I was very happy to see not only that the score was high, that I got the position, but also that my idea, that was probably my first research idea, independent idea, was welcome from the community. So the community was saying, okay, you have a very nice idea, go ahead, do it. So that was great.
Yeah.
And so today, I mean, my Marie Curie project is now officially closed. It was too short, but
Yeah.
it was great. It was, I mean, you have your independence, you can do the traveling that I love, you can meet people, meet colleagues. And so it was great.
Glad to hear that. And yes, so staying on the same channel, for instance, could you please give us a brief, yeah, more or less talk about it, but like a brief description, summary of what your project actually was or it is? Because at the end, yeah, it sounds interesting, but also, as you said, puzzling, no? Like food electronics or these kind of things. So could you please help us understand right now? It can be even in a more technical way if you want to be more specific, and then we can just go
Yeah,
dig into it.
of course, Mauricio. So ingestible electronics have been around for many years now. The first idea of an ingestible pill, it's from 1957. And it's like a pill that you can ingest and can measure some parameters. In this first pill, it was the pressure inside your gastrointestinal tract. And from there, we have seen in the last few years many commercial products. So ingestible technologies progressed quite a lot because they could take advantage of the electronics, of the advancement of electronics. In the end, an ingestible capsule that can run a test in your gastrointestinal tract is just a normal electronics product, just like the one you have in your phone, but it's in a different format. It's just miniaturized and encapsulated with materials that are safe. And ingestible technologies are great, and of course, they will progress in the next 50, 100 years. But there is a limit of these technologies. As I mentioned, they use materials and methods that are uh, that are properly of consumer electronics. So they are designed and fabricated for consumer electronics. They are just adapted for ingestible applications. But some of these components are not suitable for being ingested. For example, batteries that are in these ingestible capsules, of course, they are safely encapsulated, but the battery itself, it's not safe. So if the system fails, you can potentially have a damage of this capsule. Also, these capsules are rigid, they don't degrade. And there is a small number of cases where these capsules are retained by the body. And the retention risk, it's about 2 to 5%. It depends on the person. But if you consider to deploy this technology on a large scale, even this small percentage means a lot of cases where you need surgical removal of the device. And that's the reason why this kind of technologies, they are only used in hospitals. So the idea behind edible electronics is to try and use alternative materials that are safe for ingestion, that are degradable, and the body can actually the body can degrade the device. And so there are many materials that we that are approved as food with very interesting electronic properties. Think about when, I mean, I'm in Milan, when they want to do like a fancy pastry, they would use gold foil on the pastry. But gold is a very good electronic conductor. And also activated carbon is a material that is used in baking to have a black color of the dough. But also activated carbon is an electronic conductor. So as you see, there are some materials that we don't that we're just used in the food industry, but they have very interesting electronic properties. So in different reviews, we have recognized electronic conductors, semiconductor, insulators, ionic conductors, many different materials. So we have a library of materials that we can use to build an edible device. And my Marie Curie in particular focuses on enzymatic biosensors developed with edible materials. So we have a part of the biosensors, which is the biorecognition layer based on enzymes that are approved in food industry. So I use enzymes derived from horseradish, for example, or even glucose oxidase is used in baking or in drinks. I use also other type of oxidase enzymes that we eat every day in our food. And I use those enzymes to create the biorecognition layer of a biosensor. All the other electronic components of the biosensors are also realized with edible materials. So I use gold, I use chitosan, I use the blue pigment of the toothpaste, which is a semiconductor material.
Wow.
Yeah, so of course, this is also in collaboration with the group here in Milan of Mario Caironi, working already on edible electronics. So when I approached this group, I used my knowledge in enzymatic biosensors for point of care and tried to merge the two fields. And so I was very happy to develop one of the first edible biosensors using, of course, as I mentioned, a variety of edible material. And the idea in the application is that you have a device composed only of safe and degradable material. You can ingest it, swallow it, and the device will run a test. In my case, running a test on metabolites in the gastrointestinal tract. And then at some point when the test is done, because the test is enzymatic and it's really, I mean, it's relatively quick, it will completely degrade. So your body will be able to process it like it was normal food. So partially will be metabolized, partially will be degraded, some will be inert waste, just like our food. And the idea of the device is that it's super safe because it's material, it's food in the end. So even in, I mean, the retention risk that I mentioned at the beginning, here it's virtually zero, because even if the device fail, it's still processed by the body like food. And also, from an environmental point of view, you can actually use this on a large scale because you don't produce electronic waste, like in the case of ingestible. So I would say that edible electronics somehow originates from ingestible, but now also with my project, but other projects in this group and other groups, this is a new and emerging field of electronics.
Yes, and I think I find it amazing the fact that like everything that you mentioned, like for instance, um even the thing of the toothpaste, but not only, no? So things
Yes,
that I find amazing exactly this, and I think that's the core of what we want to do with this series, video series, because to use things, first of all, to improve, because this, I assume it has a lot of potential, both in the medical industry, so for the safety of the people, also for even, I don't know how, to get it closer to people, no? Because at
yes,
the end, it's something you can eat, so something you can even
yes.
enjoy, probably. eventually, no? So while being also tested without an invasive either apparatus or system. So it's amazing, but I think it's amazing how it reflects the way we use knowledge, no, in order to proper have a proper impact. So it's very, very interesting also the way you describe it in a way like, oh, we already eat gold, but it works also for this, no? So how
Yes.
the knowledge that gold is a good conductor or the blue dye from the toothpaste like you mentioned. So I think it's amazing. And also the fact that I think it reflects like your trajectory, the aim of the Marie Curie itself as well, no? Like this knowledge exchange
Yes.
and what can be, how beautiful is this that you had the opportunity to do the Erasmus, so to get to know not only the city, other culture, or other ways
Yes.
of doing engineering in your case, and then to get to try to pursue that, and then from there to apply it elsewhere. Because I even if it's here in Italy, but it's a different place from where you started your career. So all this knowledge transfer as well is what enriches our community, no?
It's exactly as you say, like when I moved for my second postdoc in Milan and I started to work on this new topic, I immediately triggered, like, I was like, okay, I've done this kind of device in my PhD. I could do it now with these materials, which are safer, degradable. And it was as simple as that. And then I decided to apply. But I mean, it's exactly as you describe it.
Yeah, no, it's great. It's very fascinating as well. And I actually have a lot of questions towards the technical part, but just now, I think it was already too very clear. But if not, can you please help us trying to summarize your project in like words for a broader audience
Yeah.
that is not like your inner engineering circle or like your colleagues. So
Yes.
how would you describe it?
So the aim of my project is to develop a smart candy, um, a device, a system that it is as simple as a candy. It's just eating a candy. But inside this candy, there are other materials that are there to perform a test of your gastrointestinal tract and simply measure the status. So just try to study if everything is fine with your gut health or there is something which is unbalanced. So yeah, when I talk to general audience, I always make the reference of a smart candy. It's just a candy, really. Like for the user, it's just a candy. You just eat something that is as safe as candy, can even have, as you mentioned before, a flavor because you can work with the structural material. You can make it easier for a kid or for a people with disability to run this test, which is completely non-invasive. Again, it's just as simple as eating a candy. So
Yeah,
that's the aim of the project.
that's amazing. And now also, I I remember that you also have a podcast, so that came out of this. So can you talk us a bit about that? The idea, what's the podcast about? Where can people find it?
Yeah. So that was that was an amazing opportunity of the Marie Curie program. To be fair, when I wrote my Marie Curie application, I was thinking about ways to reach more people, general audience, and talking with my partner, with my friends, and of course there is a trend. There was a trend, and there is a trend among younger people to follow and create podcasts. So the idea of the podcast, it's actually in my proposal as a deliverable of the project. So of course, when I started the project, this was a deliverable and this was top priority for me. And so the idea came just by talking with friends, but then from the idea to the realization, there was a lot of work. And my institute helped me a lot. And we ended up talking with different people, but we ended up talking with Wired, the journal Wired Italy. And this project created a lot of interest from them because they are passionate about new technologies. And I discussed with the editors and I discussed with the journalists, and we ended up creating a small podcast series of 6 episodes. And the series is called One Day We Will Eat Robot, but it's in Italian, so it's
Yeah.
Un giorno mangeremo robot. And it's available for free, of course, on the Wired website. You
Okay.
can look up, but it's also on Spotify and all the major podcast platforms. And the idea there, it's very interesting because I designed the podcast myself with the help of a journalist, Marta Abba. And the way we designed the podcast is that me and Marta, we are in the future, 12 years from now, and we see crazy technologies going around, just like the smart candy. And so we somehow talk with the inventors of this. So the first episode, it's dedicated to my Marie Curie project. But the remaining 5 episodes are dedicated to similar technologies where we talk directly with researchers to understand how the technology works. So, I mean, it was very interesting. It was something different from normal research, but I believe is just as important as what we do in the lab every day, because it's important that people understand what we are doing. And sometimes it sounds a little bit more too, sometimes can sound a little bit too simple. Of course, we want to make it simple. So even in the podcast, it was very difficult to, find the words to explain what I do and what we do to general audience. But that was an amazing outcome of the project. And if you are an Italian speaker and if you are interested, please look up and let me know what you think.
Yes, yes. Actually, I was thinking now, if you want, we can also try to write and leave the link as well for the
Of course,
podcast, for the video,
of
like in
course.
the description of the video, because I do believe also, yes, it's very interesting. It's very. I also appreciate a lot the effort because sometimes we are framed, but also I think the people that are outside our research job frame us in a way that is we only work in this and that's our narrow-minded, and
Yes,
it's true most of the time, and we have forgot in general as a community sometimes how to connect with people, no? So I think
yes,
this is very valuable also now to take advantage somehow of to seize the fact that especially young people are already very much into videos, podcasts,
yes,
etc. So to try to
yes,
do these kind of things, it's amazing. It's perfect also right now that it's in Italian because at the end we're the Italy chapter, so this is what we do. Also, especially because I think it's fine. We're doing the video right now in English to try to reach a wider audience, but for the local community, so the Italian, probably eldest people, even kids, if they understand this, as you just beautifully describe it, a candy that you can eat that might measure, like probably eventually it will turn out instead of taking a blood sample, you can measure some of those things by ingesting a pill. So it's amazing. It's
yes.
amazing to be described that way, and that's why I think it's also important to do it in even like for instance for yourself that in Italian, you're in Italy, why not? So it's a
We
great
had many
effort.
discussions about it. I completely see your point. The reason why we went for Italian is exactly what you're saying. We want to target uh, young people. We want to target older people, but especially we want to target them in a very natural and interesting way. And of course, my mother tongue is Italian, and also working with a journalist which also was from Italy, we decided to take this project more locally, so in Italian, still with a major editing, major journal, like which
Yeah.
is well known worldwide. But in this way, we could reach in a more effective way our audience. Yes.
Yes, exactly. That's beautiful. Also to get to know like that was the aim, no? So your audience was like there was a target audience and it's perfect. So I think also I would like also to say thank you for that because I would love more people. It's not that I know people is trying to do it that but it's like as an initiative, I think that's what we should be pushed. And I think also that's also one of the nice things about the Marie Curie that we are encouraged to do that, no? In the so to try to get some impactful impact from our research, which, for instance, for my personal case, I didn't think exactly about it before, but by how when I wrote the proposal, I had to thought about how can I impact,
Yeah.
so how can I reach a broader audience like you did. So it's very, very nice. And just so that we don't extend that much, because apparently we could stay here for hours.
Yes.
Normally, I like to finish with asking about how your project can impact everyday's lives for people, but I think now it has been clear so far. So I would then like to say to change it and ask you if you can finish with a small thought on how can how do you think research has in general an impact in everyday people's lives, so that if we are reaching a broadening audience, hopefully people can understand why is it important what we do, even though sometimes it seems that far, no, from
Yeah.
everyday life.
Well, it's a very interesting point. I think for me, research and science, I mean, always fascinated me. And but what people should be aware of is that research is not just something that happens in the labs or the universities. It's something we do every day. I mean, it's quiet, but we do it every day. Every time we compare some products that we want to buy, so we check for reviews, or when we check for restaurants, or even when we decide to go creative and create a new recipe. That's research. I mean, that's something you are trying. You don't know the outcome. You expect something, but you don't know. You are just doing it and collecting data and understanding what is happening. So even simple habits like asking why can change how we see the world. And so these are small acts of research that, of course, can fail and can be successful. But in any case, it helps us to move from guessing to understanding, so that next time we can do more informed choices. And like in research, the knowledge needs also to be shared. So you will talk about your new recipe with your family and with your friends, especially if it's a success. So you will say, okay, I tried a new recipe. I didn't know what to expect. It was great. You should try it. Or also the opposite. I tried this recipe. It was awful. Never, ever do this. But so in the same way, that's knowledge, right? So even if you fail, and that's also important in research, even if you fail, you have the knowledge that that particular experiment, that particular recipe will fail. So if you do the same, I mean, don't waste your time and resources, right? And in the same way, in research, we need to share with the community, with papers, with podcasts, with all we can do to share our knowledge. And but I mean, my opinion is that research, so it's not just discovering, it's just not the end of the experiment, right? It's just about cultivating curiosity and better understanding for the choices that shape even our daily life. So of course, science, what can science do in our world? Science can help us understand the world, understand our everyday life, and help us making better choices, and hopefully for, of course, a better future. That's my idea of research. And it's, I mean, the take-home message I want to deliver is exactly that research is not something we only do. We do it because it's our job, but in every day, people do it. And I think that's great. I mean, that's always what fascinates me.
Yes, I think it was, thank you for that, because I think it was a beautiful, again, way to explain it. And yes, because what we, like you said, what we do is uh, we get to we get some knowledge so that it can be applied, like in the example you gave, no? So you tried a new recipe, probably it doesn't work well, so you tell your family, don't do it this way because it will mess with the
Yeah.
things. That's the impact we have as well, no? So something that might not be that useful as trying something new, it was useful for the family to try either something great or something
Yeah.
better, not to not go through that direction. So it was great. Thank you for this, and thank you for the very lovely chat. Thank you also to everyone. We will leave in the description and also in the post, whether this is seen through the LinkedIn post or the in the YouTube channel, the link of to your podcast. I will for sure listen to it. And thank you everyone that stay with us, and stay tuned also for the next chapter where we try to give some voice and get closer to the people from our side in research to the broader audience. So thank you, Valerio, and thank you
Thank you,
everyone.
Mauricio, and thank you, everyone.
Thank you.